Hello everyone, my name is Yinlin Chen from Virginia Tech Libraries. Today I will present generalized work on serverless computing. This is today's agenda. So we want to address three problems. The first one is we don't want to maintain the cluster, even though we want to maintain the cluster, we want to reduce it to the minimum. And the second, we want to process as many as WARC files as possible, not limited by the computing resource we have locally. And the third one, we want to reduce the money and use the resource more efficiently and pay only the resource we used. So we think about to deploy our current service into the cloud computing using the serverless architectures. So in the past, we build the cluster locally using the computer source we have. So we use a budget we have and purchase server and build a cluster and makes run 24 hours and for higher students or system admin to maintain these clusters. So that's what we did in the past. So now we move into the cloud environment in the AWS. We use the serverless architectures. We still provide 24 hours service. So when we receive WARC files, we can process it and do the analysis for these WARC files. The difference right now, we use the service company provide. So we don't need to, there's no server for us to maintain. We just use the servers. And we use the resource we only need. So pay the resource we used. So in the past, we create a computing resource, but we not necessarily use all the resource. So many of the resources are waste. And when we deploy it to the cloud, we use the resource more directly. So we can control the resource we used. So how do we build this service? So we follow these four service principles. So we want to make this service, this pipeline automatically. So we use event-driven pipelines. And we implement our program and analyze logic into a Docker files. And this Docker file just do a single job to process, gather WARC files to process and analyze this. So build a single purpose. So it's easy for us to maintain. And we also want to use the resource we only need. So when we receive a new request, create a resource, process it, then terminate the resource. And also we want to see everything. Like we want to see the CPU used, log files, execution times. We want to have tools to can see everything we run for these pipelines. So this is our cluster pipeline event-driven pipeline workflow. So we submit the test file into S3 bucket. And when after the S3 bucket receive these test files, they will trigger the pipeline and the automatic create a server, process the WARC files, and we can upload the result into a bucket. So we can, based on the result in the S3 bucket, we can get a result. So we use Lambda as a microservice to communicate between different AWS service. So this is workflow visualizations. So we set this service up we upload test files into S3 bucket. And there's AWS Lambda, it's a microservice. They will get notifications from this new files upload into S3. And this Lambda receive these notifications. It will trigger the event and create test file, create files and tell AWS another AWS service, AWS page. And this page receive the notification from the AWS Lambda, and you will create multiple batch job files, and each batch job will process one WARC files. Inside this job, you will download the files from the command call data files, and after you finish process these files, you will write the results into another bucket in the AWS S3. So this is a program workflow. So you will get a file from command call, and inside this batch job, you will load the file into an archive Spark and create a CDX, get the page with links, and so save all the derivative data. And we also record the execution times and upload all the result into the S3 bucket. So we also use the programming way to create our entire service using the infrastructure as code. So you can see from left-hand side, everything is right into a call form template, and we can, through this template, we can use one-click deploy to deploy the entire service into the AWS. And we can create multiple versions to this template. So this is our example experiment setup. So we, after this service deploy in the AWS, we run 10 to 1,000 texts. So we process 10 files, from 10 files to 1,000 files, WARC files. And each text is process one common call files. Okay. And we compare on-demand instance and the SPA instance. So this service will automatically create servers, process these command call files, and we record everything. So this is information after we submit the task, and our server start processing the WARC files. So we can see the CPU, how many server create, how many running tasks, how much CPU utilizations or memory utilizations. We can see everything through the service, through the tools, monitor tools provided by the AWS. And you can see in here all the servers. So we run about from 10 to 1,000 tests. So AWS will create all these instances automatically. So they create a server to process the file. After this file being processed, all the job is finished, they will automatically terminate all these resources. So we use the resource we only need. And we also can monitor Lambda status. So how many Lambda being triggered during this process. So we can see all the successful rate, our durations, and if there's any error count in here, so we can monitor everything. And we can also monitor job process. So each file, one job process one WARC files. So you can see here we run 1,000 tasks. So there are 1,000 jobs, and they process some of these jobs currently running. So there are 1,000 in here. currently running 64 and another 963 waiting to be run. And they will create our service will create a server automatically. So you can see currently 64 is running, and we use a computer that we defined to run these jobs. So we can see everything here: how many success, how many running, how many prepare to run. So we can see everything to the GUIs in here. Also, every job have logs, so we log how much when these jobs start, when these jobs finish, and we can see total execution times and the status. So we can see everything here, and also we can see the details in the next page. So you can see every job have all the output. So how many status, and we can write some logs inside the programs, and they will print out into a log. So we log everything, and then we can see everything here. And the one we have all the log files in the A3, so we can easily write a SQL-like query language to get the result we need. So we can see after we run 1,000 jobs, and in here there are 998 job is success, okay, 2 failed, and we can see how long our service process this amount of files, and we can see each logs, and also we can see the summaries, and this is output from our programs, and we can easily write a query language to get the results. So our service based on our experience, so we can see we like take about 23 minutes to process one work files, and process like 1,000 tests took about 6 hours. Okay? And if process 10 to 100 tests, because we can create service like automatically, so process under 100 tests just like only need 30 minutes. Okay. And the cost, so on demand is more expensive, because on demand is like we as AWS create on demand, so this is the cost for on demand. Now Spark instance is like we use like bit, so we use cheaper. It will be cheaper because we bid the instance. For example, usually there is $1 for on demand instance. So we can bid like we only want to spend 40 cents for this instance. Okay, so Spark instance is more cheaper. Okay. So the success rate, so because on demand is we always guarantee to have this computer resource, so the success rate is very high. The Spark instance depends, because if we bid under the current price, the server may be terminated. Okay, so we need to run more expense to verify how much the successful rate. So the cost we can see in here. So in the past, we need to have a capital cost, but after we deploy in the serverless architectures, we pay only we used, okay? And we don't need to maintain the server anymore. So now we can pass almost any number of work files, okay? Because we just like deploy it in either in the AWS, you receive a work file, automatically create the servers to process this file, and we get a result. The entire process is automatic, okay? And we use the resource we need. We don't need to maintain the servers. Okay. So in the future work, we will figure about like extend our current extend our current program to handle more complex tasks. Okay. And also we can still, I think we still have a room to utilize our service to make more like use the CPU and memory more precisely and reduce the cost. And also we can update our program to run more efficient. And also we can run more experience to figure out how to use the Spark instance to save more cost. And also this infrastructure can be applied to other use cases. That's it. Thank you.